according to the cloud.
Organizers, did you have any intros or setup stuff, like obligatory regular stuff you needed to do?
Let's see. So, welcome everybody to Denver Gophers Meetup on second virtual online meetup. Thanks for joining. Anybody wants to have any hiring updates or anything like that? VMware is hiring, just FYI. Specifically in our MAP BU, or what they call Modern Applications Business Unit. And feel free to reach out to me on Gopher Slack or wherever, and I can give you all more information about that. Anybody else? Thanks to our sponsor, VMware, for providing the Zoom room. Zoom room. Woo! Cool. And thanks to the other hosts, Heather and Stacy, for backing me up.
All right.
All right, Kevin, go ahead.
Sounds good. So let's see. We are this session gonna essentially play around with the experimental Go generics prototype. I will not say official because the proposal has not yet been accepted, but it's gained enough traction that the core team has started writing like a prototype implementation that's actually in a semi-usable form now that we can play around with. And let's see, I will see if I can share a screen. Okay, so can you all see my screen? Is this actually too big or too small?
It looks good to me.
Okay, so in the Meetup description, there's a link to this GitLab repo. This is essentially serving as the, in lieu of slides, which I didn't have time to really go into or prepare, this is kind of serving as a list of links. Of particular interest here are, let's see, to actually start playing along with us, there are 3 ways that you can go. If you are familiar with Docker and don't mind setting up like a volume mount, if you want to use your on-host editor to edit to files through, the volume layer, you can go ahead and just go with this. This link right here. You can also, if you have Go installed right now, this is tested with, probably should work with anything after Go 1.12, but if you have a Go installation right now, there is a script in this same repo called build go to go. You can just copy it onto your local machine, assuming it's something Unix-like, which includes like Macs. And you should just be able to run it as a shell script. It will find your local Go installation and essentially clone the source code, the Go compiler source code, build a modified compiler that can do Go generics compilation, and you can just do that straight on your own machine. The third option, if you don't want to do either of those things, or you're, for example, using Windows and are not comfortable figuring out how to bootstrap yourself into one of these other approaches, you can go ahead and use an online playground for this. This does have one big limitation. Imports do not work. So you can't even import FUMPT. If you want to print things out, you have to use like the built-in, you'll see all these for any examples you see on this playground, they all use like the built-in print line function. So, but it does have the other, almost all the other features that we'd be playing with. So feel free to start downloading Docker images or running the script or hopping onto the playground now as we go into a little bit of background. So let's see. if you went to look at the on this this README here, there is a link to the proposal itself. Ignore this overview link. I realized it's actually out of date. But if you looked at this proposal link, it has a lot of minutia because it is like a specification, a proposal that you don't need to get bogged down with in order to start playing along. You can generally get pretty far just looking at what it's doing and modifying it to what you want it to do. So some highlights here on what is new, what is in the proposal being added to the Go language is, if we start simply, the generic functions essentially have an extra set of parentheses ahead of the normal parameter list that start with a type keyword. And so essentially what that declares is that this print function, for example, is a function that takes a slice of some element type, and we don't know what that element type is. Essentially, we're just saying you can pass in any element type or a slice of any kind. Could be a slice of int, could be a slice of string. Of course, you can cheat and take the easy way out and say a slice of empty interface, which is kind of like how you have to do crappy generics in Go right now. And essentially what the compiler will do is it will type check this and arrange to make an implementation that is memory safe and is able to allow your code to access any of the properties that you've described. Right now, we haven't described any properties of T. So we're essentially just saying it's an opaque type that you really can't do anything with except declare variables of that type and like pass them around. But you can't like add a number to them, increment them. You can't use square bracket index syntax of the T element itself, for example. Let's actually go ahead and see if, I'll just start in the playground. Let's see if we can replicate this. So I'll just copy paste. If we do the really simple thing, and should not have deleted that reverse function because that's actually more interesting than this print function. But so I'll bring that back. Okay. So if we just start out here, what we can do is we can call this print function and give it value of type S. This satisfies the requirement in that the argument required is a slice of something, and a slice of string is a slice of something. Let's see, 2 main functions, that's not a good thing. And let's see what else I've screwed up. Should actually, this is a WebAssembly compiler in your browser, so it's not actually like the regular playground where it's going off to run on like some server somewhere. It's just running, compiling and running in your browser. So depending on the situation, it might take a little while. So because we don't actually have the print line, or sorry, since we don't have imports in the playground, we can't actually just do the easy thing of doing a func.print line. But as you can see here, we are able to at least print out the length here. I can make this a bit better pretty quick. We can make a slice of ints. That should still work. I've changed nothing but the type. And we can just loop over this. And then we'll get on to more interesting stuff. Print line S of I. Okay, so hopefully this will work. Declared, not, that's because I don't need that. All right, let's see how that goes. Once it compiles, I'm gonna start switching over to the local version that I've got on my machine. So some interesting things here. So we are able to demonstrate that we're able to access arbitrary elements in this because it is a slice. We can just change this to a float 32, for example, and it should still work. But this is effectively, if you did func.println instead of internal println, it would just be doing reflection. So it kind of be cheating. You can take a slice of arbitrary element type, but ultimately, if you print it out, it would still be going through the normal reflected path that it does today. But we can see here that it is printing them out in a reverse order. So our reverse generic function does actually do what it is claiming to do. It takes any slice and can reverse that in place. Do we have any questions so far? Okay, let's go on to something perhaps a little bit more interesting. Let's see if we can go to type generic types. So generic types also have an extra set of parentheses. Essentially how it works is you're declaring, it doesn't have to be a struct, it can be any type under the hood, but you're essentially saying, in this case, I have a generic type S1 that has a field of type T. So what this would probably look like in practice, let's say this is like a logging type where you're just like, you're doing JSON logging, and this is, you have some common fields which don't have to be generic, like timestamps, etc. And then you have some application specific fields. You can essentially have a generic type that maybe embeds or takes a another struct as its like generic parameter, so to speak, and then is able to, in a type safe way, without using all kinds of reflection and type assertions, essentially handle that or serialize that at runtime. Right now, you don't get to do that in quite so nice a way. You have to deal with empty interfaces in order to approach that kind of problem typically. So let me see if we have more interesting for a comp sci kind of style approach. To take this even a step further, let's say that we actually wanted to introduce, like, we wanted to know something about our types rather than making them generic, like opaque types. That is where contracts come into play. So with contracts, you're essentially, it looks very much like an interface in that you're saying, here are some properties about my types. And then you're implementing types or generic functions in terms of those properties. So in this case, we have a contract that says we have two different types, a node and an edge, and they are related in these ways. The node type, pretend this is like a mini interface in there. It's saying node is a type that has an edges method that has to return a slice of edge. Now, edge is a generic type. It's a generic parameter. It's not a concrete type. So really, as long as whatever you pass in satisfies this edge part of the contract, it can be anything. And what does it have to be in order to satisfy that part of the contract? It has to have a nodes method that returns essentially a from and a to node. So you could presumably implement this in a lot of different ways. This kind of contract would be more about like the Dijkstra's algorithm or just tree spanning aspects of a like graph representation, but you could represent it as maps under the hood. You could represent it as arrays or slices, or linked, you know, just like a pointerized arbitrary graph. And as long as it implements these methods, just like an interface, it works, except unlike an interface, the compiler is free to make extra, the compiler can do two extra things. One, it can optimize this. So it is free to essentially generate or like build into the compiled binary type-specific code for performance reasons or to be more memory efficient. And it can also give you access to do things that are not based on methods. So let's see. So here's an example of a different kind of contract where in this proposal, the other thing that you can do is just essentially say, here are all the types that I could possibly use to fulfill this contract. You can mix and match, so you can say it has to be based on an int or an int date, et cetera, and it also has to have these other methods or properties. Or you can essentially just use it as a way to say, okay, I've got this matrix multiplication algorithm that just, the things have to be numbers, but we don't care what they are besides that. You can do that with this kind of approach. You are limited to those operators and like the operators and syntax that all of the types implement. So all of these types do implement all of the same operators, but if you threw in a float here, for example, floats can't use the modulo operator. So you can't use the % operator to say, give me the remainder of something, because that's not valid with floats. If we actually just went into the playground here and tried that out, I'll just say var s number of int 32, for example. I can assign it a value, say 16, and I can say s modulo equals 5, which should give me the remainder. And let's see what that spits out. Contract not in type parameter. Let me actually see. The downside of this proposal is that, one of the downsides is that it's kind of an squirrely syntax from the perspective of a lot of developers. So it's doesn't necessarily, it's not necessarily intuitive or obvious. I've found myself that I have to look up a lot of times how to actually use this. So I can try and actually just make a function out of this. Let's see, divide, or so to actually specify this, you have to not only use the type keyword and then give that type, that generic parameter name, but since it has a contract that essentially has extra stipulations that you have to adhere to, there's this third part here that's essentially saying, oh, hey, but it's also a number. And we can say n is of type, I'll just call it n for completeness. Okay, hopefully that gets me past this issue. So I don't have to look up too much of the syntax. So if we do var n int32 equals 16, and then do calc rem of n. Let's see what this says. Seems to be working. Okay, so yeah, 16 divided by 5 has a remainder of 1. So essentially what's happening here is, as a syntactic convenience, what generics will do is, if it can, just like with I colon equals 10, the language infers that that's an integer. In a similar way, it can infer, hey, you're passing in a value into calcrem with a known type, so you don't actually have to, we can infer that we're like, this function is going to be compiled as a calcrem version for int32s. So it can infer that from your parameter. Going back to what I was saying about if we added in float32 here to say it can also be float32, this actually causes a problem now, because floats don't implement the modulo operator. So as soon as we did that, we essentially contracted down what our actual function can use. We've said, hey, it can be float32, since your functions have to be able to, can only access all of the properties and operations that all of these types can use. Essentially, you are, we've now restricted this operator out of existence from the perspective of this function. We can still use something like division. That should still work fine. And in this case, it'll give a floating point number. And if we switch it to an int 32 again, it will do flooring division. But that's something to be aware of with
this. Sorry, Kevin, can I ask a quick question?
You may, of course.
Two things. One is probably the obvious thing, but just out of curiosity, in terms of the function signature, if the return were to be a separate contract, then the input, right? Because for example, say in calprem, right, you're saying type n, type n number.
Mm-hmm.
If your return wasn't type n, if you had some other type that you were returning, would you have to have this type? Would you have to like be having to have that, all that verbiage of like, say, type S, whatever, sorter?
Yeah, so there is a limitation here. So let's actually get into, let's cover that real quick. Let's say hypothetically you wanted to actually, let's just div by 5. Let's make something pretty stupid here. So this would be, you essentially, all of your types have to be specified in this, your generic types have to be specified in this initial parenthetical section, even if they apply only to the output. But also, I suspect what's going to happen is it's going to ask us to create a new contract. If not, we're lucky. But let's just say that we want to, part of this should be okay, because essentially we're just trying to, what I have in mind for this is we're essentially just saying divide by 5 and then convert to whatever m type that you want. But so if we just did it like this, there's not nearly enough information for the compiler to do what it needs to do. We're telling it, yes, like one of those parameters is in int32, but it has no idea what the second parameter is. A limitation of this design, though, is that you only get one contract per function or type. So if you actually have two type parameters of type number, you actually have to create like a throwaway contract that is called like two numbers. And these don't have to have the same names. It's just clearer if they do. And you're essentially saying m is a number. Actually, I did these in, I'm going to put the same order so it's not confusing. It's probably still confusing because they're backwards, but we're saying n is a number and m is a number. And so it's like a throwaway contract Let's see if this actually works. I think it's found contact. Okay, so when you have multiple contracts, you also have to go through this kind of like extra step, I believe, of use of contract number. Oh, whoops, that is, let's see if this works on its own. Contract number, not type. So you have to throw a lot of parentheses at it. That's getting closer to n, constant type. Okay, and sometimes to disambiguate, this is where you also have to get into, just as you specify it with an extra parenthetical section, if you ever have to resolve something, such as we're forced to because we have a return value that is not mentioned anywhere in the input, it can't infer anything from that. And it refuses for clarity to say, I think if you said var m float 32, I think it will refuse this because it's just a little bit too magical if it can infer, if it can determine what your function will be compiled as based on where you happen to store it. So let's actually see what this says.
You also need to
Okay.
change the function name, I think.
Oh, sorry. That's a good call. Okay. If there are no other obvious errors, at this point, we can call it with that same kind of extra parenthetical syntax. And we're essentially saying, all right, we want a version of this that is used for taking int32s as input, float32s as output. That's a is or should be a convention that you'd probably put your input types before your output types, but you don't have to. And untyped const instant. Oh, that's probably one of my problems. Constant to n. And at this point, I don't actually know why this is working, but missing method number, oh, that is, I probably did that part wrong. So contract, I'll see if I can find it in about 10 seconds, and if I can't, I'll just give up on that and we can go play with other things about this. Must be a type, yeah, that's another. So other backwards compatible, oh, yeah, I think that'll work. Another backwards compatibility thing is because the Go syntax copiously allows you to throw parentheses around types. In this case, you have to just like make the syntax not ambiguous. And now I don't know why it's working. So, but this is the kind of thing that you'd have to run into. Essentially, thematically, you'd have to create a throwaway type or a throwaway contract to essentially compose a new, like if you have two, if these were both of the same type, it would be easier, but we're essentially saying we have two different generic types, both of which happen to be contracts, but they are different from each other, so you can't necessarily infer any direct, like they could be the same, but they might be different. So this is the kind of syntactic hop through that you have to do. I think if this proposal gets accepted, what it would tend to lead towards is you probably not see a lot of generic cases, people designing libraries where you have to return like where you say, I'm returning a generic type that's potentially completely unrelated from the input, because to actually call it, you have to jump through these hoops. And I've read the proposal like twice now, and I wasn't able to figure it out on the fly here. So it has, I imagine if it's accepted in this form, people shy away from that in terms of their API design, because it's a big hole. You can specify it that way, and there may be some common patterns that come out of it if that really becomes a useful thing, where you essentially just create a wrapper type that's a little bit clearer, or a wrapper function. But yeah, it's a pitfall. You had a second question, Stephen?
I did, but I think we actually ended up covering it in the course of covering the possible outputs.
I do tend to get ahead of myself.
Well, I also have a young puppy on my lap, so I'm also like constantly, I'm being very distracted. But yeah, no, I think that probably that covers it for now. And if I think of another question, I'll just raise it then. Thanks, though, Kevin.
Okay. I think at this point it would be good to just have y'all start playing with stuff. Like what, if you go to the Go repo, there is the link to the proposal. There's also, I'll send it in Zoom chat. For anybody using the playground, there's this blog post with a few other examples. I don't even know how to do Zoom chats. Oh, there we go, when I'm sharing. Okay, that is in the Zoom chat. I'll make sure to update, for anybody who's watching this recording, I'll make sure to update the repo with this link as well. But there are some extra examples in here that you can play around with, in addition to those examples that are in the proposal itself. And I do have a little bit of an ulterior motive because of some of the pitfalls of this. I've started like drafting a proposal tweak proposal, where I want them to, like, I'm proposing that they adjust the syntax. In the process of that, I've come to realize that a lot of the semantic decisions are there for a reason. It's not particularly arbitrary. I tripped over the same thing, so I'm like, I see why they did that. But I think the syntax is pretty unintuitive. So I kind of, as part of this, want to figure out what you all trip up on, especially, and kind of use that to gather input. I do have in this README in this repo a design meetup feedback form, and that has some questions along the lines of like, what did you like about the proposal? What did you not like about the proposal, etc. And if the Go core team or something, if I submit this proposal and they're like, give me some extra, examples of people who tripped up on this, I could potentially use that in that way. But what do you all want to try and build? Like, is there something that is just like, oh man, I wish I had generics to do this, or I have like 5 or 6 of the same type of function just stamped out for different types that you'd like to play around with?
Well, for one, I think what I would probably play around with is, you already know the Go pipeline thing I did, that abomination I did ages ago. That's one that I think there's enough like unit tests in place and stuff where like playing around with that code could be interesting.
Yeah. Let me see if we can actually, while I'm typing up a potential way to do that, does anybody else have other things that they'd like to play around with? Which you don't have to answer now. Let's see. So to like for the pipeline stuff that you kind of described, nobody else has background on that, of course, but a lot of it is serving the same role, as I recall, that you tend to see in like map or reduce functions in like Python or other languages. You can now do that pretty well with this proposal. So if you've ever found yourself just like you might find yourself in this kind of dilemma where it's like, well, I'd like to have a generic way to just transform like a slice of one type into a slice of a different type, for example, but I'm just not doing it enough to where it's actually worth making like a reusable kind of thing, or the language itself doesn't allow me to make a reusable type of thing. So I end up just making like concrete for loops for each case. You can do better now. So let's see if we can actually get that done. Essentially, all I'm saying is, and I hope this doesn't fail miserably, but I'm saying I have a generic map function which takes a generic in the sense that it operates on slices, not generic in the sense that it can like do channels and other things too. But I'm saying, all right, like I want to iterate over this slice V's of type T, use this function that you pass in, which takes T's and makes U's, and then spit out a slice of U's. So with this kind of thing, it should be pretty doable. I'll actually just call this T's, and I'll call this U's. And I think we can actually do, I don't want to steal the thunder. Like, would you like to try doing this on the fly with puppy on your lap pressure, Stephen?
Well, probably not, but
Sounds like that's a maybe.
yeah, definitely maybe.
Here, I'll share this.
Yeah.
So you can pick up where I left off, and I can stop sharing and shut up because my mouth is getting a little dry anyway. You might have to actually drag and copy that whole link in the chat, but if you could share, you might have more luck. You might have puppy luck.
Yeah. Well, it looks like actually when I open that up, does this not persist like the code that you have? It looks like, sorry, when I open the link, it kind of looks like I just go back to the initial.
Yeah, don't click on the link, copy and paste the whole link. Yeah.
And in case anyone's doubting the veracity of my statements, that's a puppy.
That is a big puppy. Please do share if you could, though.
Yeah, I will. So one sec. All right. You guys all see this in my abomination of number of tabs?
Yeah, we can see your screen.
Okay. So
I'll add a little bit of commentary as he starts typing. One nice thing about this is, unlike the prior example with div by 5 and the 2 numbers thing, this U type that we're returning actually is related to the input because we're passing in a function that mentions U. So we won't necessarily have to go through that dance of like when we call it saying, oh, and your U type is actually this. The compiler should be able to infer that, or so we'll see.
Yeah. I assume that access is going to work, right? That seems.
Should. I mean, you could use a range loop, but nobody's looking.
So let's say. Sorry. He is now getting excited.
Since this doesn't have imports, you might need to use that print function that I made that craftily prints out
Yeah.
So you can just, yeah.
Let's do. Well, here's what I'll do. This. Let's see. And so I'm just said it would have to be. Yeah. Call me out if I'm doing something very stupid, which I'm probably doing.
I mean, for one, you can't actually use func.sprintf since that's an import.
Duh. Well, that's
You
an obvious.
could,
That's an.
you could, can't use strconv either. You could just do something like, I mean, if you wanted something that proves that this is real,
Yeah.
but is not like a super toy, you could have something that takes strings as input and returns bytes as output and just selects like the third byte of every string and panics if you give it a non 3+ byte string.
Well, you should be able
Because
to. Yeah. I wonder. Well, can anyone pull up? Presumably, the source code is out there somewhere for printf, right?
oh man, are you serious? That it's not an all-in-one function. It uses internal imports. It would be
Well,
that would be like its own how the standard library packages work
Well, it was
kind of
aspirate.
talk.
Let's do. Right, I don't have.
Yeah, at that point you
Wait,
can just do a print line.
Does print take any formatting directives?
No,
No.
you want to go with print line, and that'll space separate the parameters.
I chose the wrong place to put the.
Oh, get rid of all that damn 2-number crap.
Oh yeah.
Oh, okay. No, that's pretty easy because you're just declaring on line 41 something that's opposite from the truth.
Yeah. Sorry, that's AC starting up back there. Sorry.
On line 38, you still have map int string.
Oh yeah.
There you go. Yeah.
Thanks.
Yeah, no problem.
So I'm gratified that something actually more useful than what I was trying to do actually works. So that's a positive. Things that are potentially useful can work.
Yeah.
One thing I'd like you to try is just get rid of that, what you probably had thought as obligatory set of parentheses there on line 30 that says it's a map of ints to float. Sorry, line 38.
Okay. So,
So that extra set of parentheses compared to what you'd normally have, it should, if you get rid of that, it should be able to infer entirely, because your function, essentially your function signature tells it, gives it enough information to deduce what the U type should be.
and that feels more idiomatic then too.
Yeah. Yeah, essentially, as a general rule, if you find yourself having, you're forced to do this when you're declaring types, but you are, consequently, I figured out what I did wrong with that previous contract thing, but you're forced to pass in like the type when you're saying, I want a graph from this node type to that edge type. But you're not forced to do that with functions. And if you do have to do that with functions, it's probably a code smell.
Yeah.
Like a design smell in most cases. I'm sure there are many meaningful, useful algorithms that you could do without that, but or where you might have to pass in something to help the compiler along. But so far, most of the useful things I've seen don't need that.
It's nice. And there's I'm actually probably gonna have to drop off soon because I think the puppy's getting hungry. But is there like, what does it look like to say pass like contracts on channels? What's that kind of look
So here's what contracts. So contracts are not interfaces. So you can't actually say, when you say I have a channel, you can't say I have a channel of contract type. That's actually what I screwed up with on my two number thing, is because I was trying to say this variable has a contract type. You can't do that. You can only essentially use contracts to refine what a function can do with your types.
So you couldn't do this, right?
No, you can't do that. You could make a type number. So you can actually make a generic type that's called number, who takes a type parameter.
Right.
So it'll look probably a little bit squirrely because we already have a contract called number. So it'd be a weird kind of naming problem. What do you call the contract versus the actual type that uses it?
Right.
And you probably wouldn't actually write code like this, because if you're doing this, you're probably just trying to like have your cake and eat it too, have like a number type that has some additional methods on it, which usually isn't that valuable. But you can absolutely make generic function types. If actually, let's try that. Change your map function, just like copy and paste it into something that's like map chan or something, and change all the slices to channels of those types. And there's this distinction here, like you can't in function main say I have a type, I have some generic, a variable of generic type, because in main, everything kind of needs to be concrete. It's only when you pass it through like a function call layer can you actually like go into the generics land. At the application level, you kind of know the data types that you're dealing with, and you just want generic functions that know how to handle those. Yeah, that's not something you do within a function body, like to say, I have some completely miscellaneous generic type that, you know, the compiler has to guess on. I'm gonna, just for fun, pretend that TCH is short for T'Challa.
Sorry, I didn't realize I was muted again. Yeah, I like jaw. That's solid. Oh. So there's a puppy adjusting positions on my lap. So
I've got to head out here. Nice to see everybody, and thanks, Kevin.
yeah.
It's nice to see you. Thanks for coming.
Yeah.
See ya.
I feel like I'm going to be like way better at programming with distractions now that I've had to deal with my cat for months on end, constantly bothering me while trying to write code.
If you thought pair programming was hard before, right?
Yeah.
So let's see.
By that token, YouTube is full of pair programming videos.
I was like really itching to go back to the office, and that the longer that we're home, like this is bad because now I'm like, now I don't want to come out. Like, so.
I'm sorry. I'm terrible at talking while I'm writing. So I'm incapable of doing two things at the same time. Oh, I never used the function.
Oh, hey.
I'm
Nice.
surprised that worked. That's sweet.
What are you filling that with?
The channels?
Yeah, I don't see where you're doing your send.
Oh, sorry. It's down here.
Oh,
Yeah.
okay,
Sorry, I kept the old code because I'm lazy.
good.
Yeah.
All right.
Yeah, that's actually, that were kind of better than expected. So I guess as long as you only do something like this, then, so basically at the top level, you can use like generic channels, but if you have like a function like this of like, hey, give me a channel of some generic type, I will give you another channel of some generic type, and that would work.
Yeah, I mean, so to that point, at the top level, what do generics even mean?
Right.
Like generics is a library concept.
Yeah.
If for generics at the top level to really be meaningful, you'd have to be able to say, I want to invoke this program, like launch this program with inst this time around. And you'd essentially need to not have a compiler for that. You'd need an interpreter. And so generics just can't happen at the top level.
Well, is there anyone else want to play around with it? I'm sufficiently distracted by the little pup.
For those of you who wanted to play around at home by chance, on your own machines, I want to show you real quick how to, if you can hop off sharing.
Yeah, I'll stop sharing.
essentially, it's the same if you do it in the Docker container, but it'd be in the Docker container. If you happen to, in this Go Meetup directory, I've essentially run the build go to go. I'll get rid of this other. So I've run the build go to go scripts, and as long as I have a Go compiler and Git, it should just work. Let me know if it doesn't. But it produced this go to go roots, and as well as a source directory. That source directory is kind of like a Go path, but for Go to generic stuff. So it's pre-filled with all of your, the install script will say, hey, here's some environment variables to update your path and to set the special go to path variable so that you can actually use this. So if you copy and paste those into your shell or set them in your profile or something like that, it should start working. But this source directory essentially behaves like a Go path, but for source. All of the examples that came with the proposal or with the prototype implementation kind of look like are pretending to be like standard library style packages where they don't have like URL style paths. They just have like single name paths. So all of these ones in purple are the ones that came with it. Some of them are crappy, some of them are okay. Just to show you that in this case, we can, when you're not doing it in that online playground, you can use imports. I essentially copied what Stephen had been doing. The difference here is you call it a .go_to file. If and when this actually gets launched, they're just going to be called Go files, but just so it doesn't trip up any like the regular compiler, you have a different file name extension. And so here I've got an actual fumpt.printf call with a fumpt import, which is so nice to have when you've been in a world where you don't have imports. Oh my gosh. And it's pretty much the same thing as that highlighting's not working, as what Stephen had been doing. And the way that you do this, you don't actually get to use the regular Go commands. You'll have in your path, assuming you paste that environment variable that it tells you to do, a go-to-go binary. And this go-to-go binary, essentially what it's doing is it's taking, it's called go-to-go because it's a transpiler. It turns your go-to source code into go1 source code. And it's really, the output is actually not something you'd ever accept, because if I just said this, oh, can I use type T, value type, variable type?
I think
Probably.
you have that last change I made where you have to call, the FN on T.
Oh, yeah. Moderately great minds think alike. Okay, so if we look at this produced map.go, this translate thing is subcommand is something you'd use if you're debugging or looking into it. But as you can see, it's essentially like created Sanskrit here in order to have things that are technically valid Go identifiers, but don't collide with anything you'd ever write. And you can see that it's like, here's my int to float 32 version of this. And it actually did a pretty crappy job of, if I save that, okay, it'll go fumpt a little bit better. And it adds some things in here that don't actually make a lot of sense. You can't actually go build this because you have to have a special import path. So this output is just for curiosity. It's not how the final implementation will be by any stretch. What you'll probably use are go build, run, or test. I'll just go ahead and do go build. And that will produce just a regular Go binary like you'd expect. And now with fumpt, essentially, I'll look at the code again. Map.go_to. I'm taking 1, 2, 3. I'll do something a little more fun here, maybe. 32, that divided by 2. So we should get some more interesting this time I'll go ahead and do go to go run, and just like go run, you have to pass the file name. So it actually did show int inputs that turned into floats, and there's no way you could divide ints into, you know, half integers. So obviously it's working. So you're not going to be able to play around with this with editor integration unless you know how to like configure your editor to pretend this is the actual Go compiler. But you can do it on the command line, and you can do it in Docker. If you use the Docker approach, you'll probably have to set up volumes to do anything fun, but all of your environment variables will be pre-set up. So that's what I wanted to show you there. Is there anything else somebody really wants to try? You don't have to be on the spot if you want me to try it. Nobody's had anything where they're like, oh, in other languages. Damn you, Gopher. Stuffed animal abuse is a crime, but I'm going to do it anyway. All right. Well, sounds like that's a no at this time. So yeah, I guess for the tail end of this, if you've played around with this and have some insights into like, hey, this stuff is good, this stuff is bad, this thing is really problematic and untenable, go tell the Go team. Well, in that case, go tell the Go team, but also feel free to let me know through this web form. If you've got any questions on how to do things, like if you want to try something, I think what you'll find is that there will almost certainly be a Go generics feature that's integrated into the language, maybe in the next couple of years. And it will probably look more like this than it will look different than this. So anything that you play around with this time around, unlike Heather with the 2018 generics proposal, you're probably going to be, you know, set up for success early on. So if you do want to play around with this, if you run into something that you're trying to do, but it's like, it is a weird proposal, it is a weird implementation. So you will run into things where it's like, how do I even do that? Feel free to ping the Denver Slack channel, or there is the generics Slack channel on, that would actually be a better place for, let's see. Yeah, it's just called generics. And I believe that some of the core team that actually works on this stuff is watching that. So if you run into something that's really hard to do, they'd love to know. So I guess that's it for me. Keep in touch.
Thank you, Kevin. That was really interesting.
That's awesome.
That was great. Should I stop recording this? I think we're good.
Unless there's any like
Anything specific, just that we'll probably continue to try to do this. It gets harder and harder to find talks. So yeah, if there's something that anyone wants to talk about, this is a good forum. Otherwise, we can always just hang out. There's that too.
Just for anybody listening, that's how I actually was able to do this, because there were no talks, and if they let me on, like anybody can do something. So kind of like bottom of the barrel.
Not true, not true. This was a great talk, by the way. This was cool.
It's a hard. You're a hard act to follow, Kevin. In all matters related to Go or programming in general. But I'll send you guys something though, because I actually I was gonna give a talk at GoCon Canada, and obviously GoCon Canada got canceled. So now it's just a matter of actually putting together the talk materials, but it shouldn't take me too long. So I hopefully I'll be able to have something for you guys.
That'd be sweet.
Yeah.
We'd love to have your talk on off Broadway.
on second city.
I'm treating GopherCon Canada as off Broadway in this case.
Last call, any other job openings or anything else? All right, I'm gonna stop recording.